Hello students, welcome to the class. So in the previous class we have discussed regarding the methods of preparation of hydrogen, and one of the method what we had discussed was using metals like zinc with dilute sulfuric acid. Okay, so when we use zinc with dilute sulfuric acid, yes, this is the method of preparation of pure hydrogen, we can say. It gives zinc sulfate and hydrogen. Even magnesium can be used here. Now the question is, can we use concentrated sulfuric acid and pure zinc in the preparation of hydrogen? See, we have to be very careful. Pure zinc is not used for the preparation of hydrogen, as the rate of reaction of pure zinc with dilute sulfuric acid is very low. So we cannot use pure zinc because it is non-porous and reaction will be slow. Reaction will occur at a slow speed. So we cannot get H hydrogen gas with that purity. The impurities in zinc help in the constitute of electrochemical couple and speed up the reaction. So impurities which are present in the zinc, they will act as catalyst. Therefore, we cannot use pure zinc here. We have to use impure zinc only for preparing hydrogen gas. So what will the impurities do? They will speed up the reaction. If you use pure zinc, the reaction will become slow. First point. Second point is concentrated sulfuric acid cannot be used. Yes. So if you use concentrated sulfuric acid, it acts as oxidizing agent and itself gets reduced. So the reaction would be, if you use concentrated sulfuric acid, the reaction would be Zn plus concentrated sulfuric acid gives us no doubt ZnSO4. But since it acts as oxidizing agent, it will oxidize hydrogen to water. It will oxidize hydrogen formed to water and itself gets reduced to sulfur dioxide. That's the reason we cannot use concentrated sulfuric acid. We need to use what? Dilute sulfuric acid. Then only we will get hydrogen gas. Otherwise, if you use concentrated sulfuric acid and pure zinc, what will happen? With concentrated sulfuric acid and pure zinc, we will not get hydrogen gas. So because pure zinc, reaction will become slow. And with concentrated sulfuric acid, it acts as oxidizing agent. It will oxidize hydrogen to water and itself gets reduced to sulfur dioxide. Yes, that's the reason when we are preparing, that is a laboratory method for preparing hydrogen gas using zinc and dilute H2SO4. It must be noted that we need to use impure zinc because impurities in the zinc act as catalyst, and we need to use dilute sulfuric acid. Okay, fine. Moving to the physical properties of dihydrogen, that is hydrogen gas. At room temperature, this diatomic molecule of hydrogen, it is found in gaseous state. Yes, it is found in gaseous state at room temperature. Okay, moving next point, it is absolutely colorless, tasteless, odorless, and makes it very difficult to very hard to detect if there is any leakage, because hydrogen is highly combustible, or you can say inflammable gas. It burns very vigorously. That's the reason we cannot detect. Since since it is not having any odor, no color, no taste, we cannot detect its leakage. It is the lightest element of our periodic table or in the universe and has the molecular weight of 1.00794 unified mass, or you can take it as 1.008 unified mass. So at standard temperature and pressure, it exists as gaseous state. Okay, it has lowest density of all elements. The density of hydrogen is least. It is highly combustible or inflammable. On combustion, it produces water, also burns with flame, also burns with blue colored flame. It liquefies at low temperatures of nearly minus 250 degrees Celsius. Minus 250 degrees Celsius. Further, if you look at the atomic radius of hydrogen, I'm talking about atomic radius. Yes, in picometers, if you want to discuss, the atomic radius of hydrogen is 37 picometers. And hydrogen molecule bond length of hydrogen molecule is how much? It is 74 picometers. 74 picometers. If you take hydride, the ionic radius of hydride, is 210 picometers. Yes, when anion is formed, the bond length increases, right? So ionic radius of hydride is 210 picometers. Ionization energy, how much we have seen? It is 1312 kilojoules per mole. Its electron gain enthalpy, is minus 72.8 kilojoules per mole. Yes, that much energy is released when it gains an electron. And on Pauling's scale, the electronegativity value of hydrogen is 2.1. This is a bridging line between metals and non-metals. Electronegativity value less than 2.1 are metals, and more than 2.1 are non-metals. Yes, non-metals. So these are some basic properties. If you look at few more basic properties, if you look at the melting point of hydrogen, the melting point of hydrogen is 13.99 Kelvin. Yes, converting this value into Celsius scale, melting point of hydrogen, dihydrogen, can be represented as minus 259.16 degrees Celsius. Yes, melting point 259, very less, minus 259.16. Boiling point of hydrogen, it is associated with hydrogen. If you see, it is 20.271 Kelvin. Yes, and if you want it in Celsius scale, how much it is? Minus 252.879 degrees Celsius, boiling point. Latent heat means what? Latent heat means it is hidden heat of fusion. That means fusion means what? Melting. Associated with hydrogen molecule, it corresponds to 0.117 kilojoules per mole. Latent heat of fusion of hydrogen. Latent heat of vaporization, that is converting liquid into vapors, converting liquid into gas, of hydrogen is 0.904 kilojoules per mole. 0.904 kilojoules per mole. Molar heat capacity, that is heat capacity of 1 mole of hydrogen gas. Yes, molar heat capacity of hydrogen is roughly taken to be 28.83 joules per mole per Kelvin. This is the molar heat capacity. And even see the speed of sound when it propagates through gaseous hydrogen. So speed of sound through gaseous hydrogen. Gaseous hydrogen, it is 1310 meters per second. 1310 meters per second. So these are all what? Physical parameters of hydrogen gas. Physical parameters of hydrogen gas. Yes. And we have discussed about hydrogen gas applications very well. In chemical industry, in petroleum industry, large quantities of hydrogen is required. So that it helps in refining of fossil fuels. Even in ammonia manufacture. Yes. In ammonia manufacture, we use N2 plus H2 gas. Then only NH3 is manufactured. Yes. It uses dihydrogen for the process of hydrodesulfurization, hydrodealkalization, hydrocracking, wherein we use hydrogen for braking purpose. Okay. Then, for example, this compound can be used as hydrogenating agent, addition of hydrogen, especially to increase the saturation level of unsaturated fats and oils. Yes. So this is all about some physical properties and physical applications of hydrogen. So atomic radius 37 picometers, bond length in hydrogen molecule 74, ionic radius 210 picometers, ionization energy 1312 kilojoules per mole, electron gain enthalpy minus 72.8 kilojoules per mole. On Pauling scale, electronegativity value is 2.1. Distinction between metals and non-metals. Less than 2.1 metals, more than 2.1 non-metals. Melting point of hydrogen is 13.99 Kelvin or minus 259.16 degrees Celsius. Boiling point is so much, minus 252.879 degrees Celsius. Latent heat of fusion 0.117 kilojoules per mole. Vaporization 0.904 kilojoules per mole. Molar heat capacity is roughly 28.83 joules per Kelvin per mole. Speed of sound through gaseous hydrogen is 1310 meters per second. Yes. So this is the properties of physical properties of hydrogen. Physical properties of hydrogen. Yes. Coming to the chemical properties of hydrogen. Chemical properties of hydrogen. Yes. Okay. So what are the chemical properties of hydrogen? Hydrogen is represented by its symbol H. However, in nature, it occurs in diatomic state and it is represented as H2, called as dihydrogen. Dihydrogen. Okay. Then hydrogen has no effect. Hydrogen has no effect on litmus paper. It has got no effects on litmus paper. That is, it is neutral, neither acidic nor basic. Yes, neither it is acidic nor it is basic. Okay. Dihydrogen is a non-metal. Dihydrogen is a non-metal. That means what? We consider it as non-metal. It shows the properties of all non-metals. Next one, it is fairly a non-reactive in nature because it is a stable molecule. It is not very reactive. Yes. So this is brief introduction regarding properties. Dihydrogen has high enthalpy due to its stable HH bond. Enthalpy is very high. It is an oxidizing agent when reacting with metals because it forms what? Metal hydrides. It will take electrons from metals. Therefore, it is oxidizing agent. Reacts with unsaturated hydrocarbons to form saturated hydrocarbons. It is undergoing addition reaction here. Reduces metal oxides of metals, less reactive than iron. So we will see these reactions one by one. So when we talk about the chemical properties of hydrogen, yes. Hydrogen, or you can call it as dihydrogen. Okay, fine. So dihydrogen is quite stable. Yes, before discussing the chemical properties, dihydrogen, it is quite stable and therefore it dissociates into hydrogen atoms only when it is heated above 2000 Kelvin. So hydrogen, since it is very stable, if you want it into hydrogen atoms, you need to heat it above 2000 Kelvin. Above 2000 Kelvin, you will get 2 hydrogen atoms. Okay. Its bond dissociation energy is very high. That is H2 becoming H plus S, H, breaking the bond. Bond dissociation energy, or you can say bond enthalpy, it is very high. How much it is? It is 435.9 kilojoules per mole. 435.9 kilojoules per mole. So because of this high bond dissociation energy, hydrogen is not very reactive. It is not very reactive. Just now we discussed how much it is. I am saying here. Okay, it is not very reactive. However, it combines with many elements and compounds. It combines with many other elements and compounds. The first one is action with metals. How does hydrogen react with metals? With metals. Okay, you know that hydrogen, we just now said hydrogen is it is electronegative and metals are electropositive. So it combines with metals, say sodium. Hydrogen combines with metals, say sodium, and forms hydrides. I can give you general representation. Metal plus hydrogen, it forms metal hydrides. It forms metal hydrides. Yes, metal hydrides are formed. For example, sodium hydride. You take potassium plus hydrogen, potassium hydride, KH. Yes, even you take magnesium plus hydrogen, it forms magnesium hydride, MgH2. It differs depending upon the valency of the metal. You take calcium plus hydride, it forms hydrogen calcium hydride. And in case of metal hydrides, what is the nature? In case of metal hydrides, here metals will have positive charge and hydrogen will have negative charge. So metals lose electrons, whereas hydrogen gains electrons. Understanding? So it is metal hydride. Okay. This is first reaction. Okay. So with the transition elements, even metals, transition elements are also metals. So with the transition elements, or you can say with the transition metals, that is elements of D block. What are transition metals? I have told you they are elements of D block, such as palladium you take, Pd, nickel you take, platinum you take. Yes. So with all these, dihydrogen forms interstitial hydrides. When you combine it with hydrogen, they will form interstitial metal hydrides. Interstitial metal hydrides. It forms interstitial metal hydrides, in which the small molecules of dihydrogen, small H2 molecules, occupy interstitial sites. Interstitial sites are nothing but gaps. Interstitial sites are nothing but gaps in the crystal lattice of these hydrides. So therefore, what will happen is formation of interstitial hydrides, the metals absorb large volume of hydrogen on their surface. So this property, the property of adsorption, that is on the surface, adsorption of gas by metal. So on this metal, on nickel metal, say, hydrogen gas gets adsorbed. There are certain sites. Yes, we call them interstitial sites. We call them active sites. So the property of adsorption of gas by metal, this property is called as, occlusion. What it is called as? Occlusion. So property of adsorption of gas by metal is called occlusion, and the gas is called occluded gas. So I can call it as occluded hydrogen. Means what? The hydrogen which has adsorbed. Occluded hydrogen. Yes. So this occluded hydrogen can be liberated from the metals. You can liberate it. Liberated from metals by how? By heating. Yes, that too, not just heating, by strong heating, you can liberate the gas. It can be liberated. The gas can be liberated. So occluded hydrogen it is called. So it is occlusion, property of adsorption of gas on a metal. We call it as occlusion. Yes. Then, so just now we had seen it reacts with non-metals. Here one of the property we had discussed that it reacts with non-metals. First one what we saw was reaction with metals. Second one is reaction with non-metals. With non-metals. Okay. So how do hydrogen reacts with non-metals? Hydrogen reacts with non-metals and forms different compounds. Like for example, H2 plus O2. Yes. This is not at normal temperature. At 970 Kelvin, say, it forms H2O. Balance it. So it will form H2O. Then N2 plus H2 at high temperature, say 750 Kelvin temperature, high pressure, in presence of iron as catalyst, molybdenum as promoter, it will form ammonia, NH3. It will form ammonia. Ammonia is formed. Haber's process it is called. Then H2 reacts with fluorine in dark to form hydrogen fluoride, HF. Hydrogen fluoride. H2 reacts with chlorine in presence of sunlight. In presence of sunlight, say at 673 Kelvin temperature and pressure, to form HCl. Even H2 reacts with bromine to form HBr. So with halogens, it will form what? It will form hydra acids, you can call them. H2 reacts with iodine at say around, yes, I will mention it like this, at around 673 Kelvin temperature in presence of platinum, it forms Hi. See, it reacts with all the halogens. H2 reacts with halogens are represented as X2 to form hydra acids. They are called hydra acids, or you can call them mineral acids. And reactivity of halogen towards dihydrogen decreases like this. Fluorine is most reactive, then comes chlorine, then comes bromine, and then comes iodine. So see the reactivity. Even at dark, it will react. Then here 673 Kelvin. Then here HBr. Reactivity changes like this. So see the reactivity of halogens proceeds like this. Fluorine reacts in dark, chlorine in presence of sunlight, bromine reacts upon heating. Yes, bromine reacts upon heating, while iodine occurs in presence of a catalyst. See, only in presence of catalyst at high temperature, it reacts to form hydra acids. So this is the reaction with non-metals. One more we had seen, that is reaction with hydrocarbons. Reaction with hydrocarbons. Yes. So hydrogen reacts with unsaturated hydrocarbons and forms saturated hydrocarbons. So this is an example for hydrogenation of the oils actually. Yes. So what happens here is hydrogen, as I said, it reacts with unsaturated hydrocarbons. Unsaturated hydrocarbons means which contain double or triple bonds. Yes. And they react with unsaturated hydrocarbon to give saturated hydrocarbon. Saturated hydrocarbon. Okay. So let me give you an example to show you this reaction. Let me say I have taken unsaturated hydrocarbon CH2 double bond CH2. Hydrogen reacts with this unsaturated hydrocarbon to form. So the addition of hydrogen across the double bond takes place. It will give me CH3. Yes, where there is double bond or triple bond, their addition occurs. So CH plus hydrogen, what happens? Hydrogen gets added here, CH2 double bond CH2. Again, you take one more hydrogen molecule, it will add up and give me CH3. So can you see here? This is unsaturated hydrocarbon. That means there is double bond or a